All right, so since the ladder wants to slide out, friction acts this way. So there's force of friction. The ground pushes up with a normal force. The wall pushes out on the ladder. And it's virtually impossible to solve if there's friction on the wall. So every time you have a ladder problem, the wall is going to have no friction because it makes it too hard to solve.
Really?
Yeah. Virtually impossible. All right. The ladder is 5.5 meters up on the wall. See? 5.5 meters up on the wall. It's 8 meters long. And then you have two things that are trying to make it move. You have this painter. I have no idea where the painter's standing. That's what we're trying to find. So here's the painter, who weighs 1,350 newtons. And he's some distance x. And then it's a uniform ladder that weighs 140. So if it's uniform, where is that at? At the middle. So that distance is 4. All right. The first challenge is to be able to draw the free body diagram. What do we call that? So let's see if today has reviewed anything. This is an equilibrium, so there are 3 equations that must be true. X, Y, and torque. Right? So if nothing else, when I give you this on your final, all of you will at least be able to write these 3 equations.
So is this from chapter 9?
No. This is just a different type of torque problem. 9 is about pressure, I think. Yeah, not the ideal gas law, but yeah.
It's so easy.
I was your chemistry teacher, don't you remember? You were in my chemistry class. You're a savant. I know that if you don't want to lose money, don't go to Vegas. Just a little friendly advice. Yeah, Vegas has gotten really expensive. It used to be you could go there on a dime.
You can still go to the old strip and it's cheaper.
Yeah, it's not bad. We went downtown. Yeah, I like downtown, actually.
I've never been to Vegas.
All right, so let's look at the horizontals. So, Aaron, in the x direction, which forces are pointed to the right? And then to the left? Good. And then the up and downs, Todd?
FM is up. The weight of the ladder and climber is down.
So do you see we can get the normal force right away? Because all we have to do is solve it. So 1350, 140, 1490.
Now we know what the force of friction is.
Yeah, and if we know the normal force, now we can get what force of friction is. In case you've forgotten the formula for friction, mu times the normal. And if you read the problem, right here it tells you that the coefficient is 0.4. All right, we're golden. 0.4 times 1490, 596. All right, but now, here comes the tough part. The torque. All right. I don't know if you recall when we first started torque, I told you that when the object is at an angle, like the ladder is at an angle, to find the torque, the best thing to do is to take the force and then figure out this perpendicular distance to that force. Okay? So we need to figure out the perpendicular distance to the man and then the perpendicular distance to the ladder. And then the wall, the perpendicular distance for the wall is just that height. It's 5.5.
Alright, what are we trying to find? This distance?
We're trying to find, see how the tail's here?
Yeah.
So the perpendicular distance would basically, here's the pivot point.
Right.
So the perpendicular distance would be from the tail to where the pivot point is. See how this one's pointed this way? So the perpendicular distance is from the.
So technically it's like the horizontal.
Right. Okay. Is there anyone who doesn't really understand why I'm picking this as my pivot point?
Do you want to find the angle?
Oh, yes, we need that angle. So thanks. So if I want that angle, I have opposite and hypotenuse.
It's 5.81 meters. It's 43.43 degrees.
Yeah, inverse sine of 5.5
That's not like this.
over
Yeah,
8.
whatever.
And you said the angle is 43 point what?
43.
So 43.4 degrees.
Yeah.
All right, so here we go. This side, I'll draw it up here.
Be easier to see.
So the painter is X away. This angle is 43.4. So the distance we need is this. That's the adjacent side, so it's hypotenuse times the cosine of the angle. Someone punch cosine 43.4.
0.727.
Point what?
72. Yeah, we're assuming
0.727. X. That's his distance. So the torque from the painter is going to be 1350 times 0.72x plus, okay, the ladder. So let me.
How'd you figure out the 0.72x?
Because it's adjacent side is hypotenuse times the cosine of the angle. If you take cosine of 43.4, you should get 0.7.
Because we don't know how far.
We don't know how far the guy is, so that's X.
Oh.
That's what we're trying to find. Now for the next one, the ladder, we know this is 4, so we need that distance. So that's 4 times the cosine of 43.4. 2.91. So 140 is the force. 2.91 is the distance. Minus force of the wall, which we know, we found it in this part, 596 times its distance, 5.5. All right, we have one unknown. Life is good. So now we solve. 1350.
So do you know the ladder's torque
Yeah.
at the top?
You mean the weight of the ladder's torque?
No, what did you put minus? You put minus.
Because the wall is going to wants to make it torque counterclockwise.
Okay.
So do you see this? The weight of the man is going to make it want to go clockwise. The weight of the ladder is going to want to make it go clockwise.
Why'd you multiply it by 5.5?
Because that's the perpendicular distance.
Shouldn't be the.
It's, remember we talked about how the vector's pointed that way?
Because it's adjacent.
Right. So 98.5x plus 140 times 407. Three, 2, 7, 8. So our painter can go about 2.92 meters up the ladder before it starts to slide.
I know you just answered this, but how do you know it's on minus for the whole wall?
Oh. Because if you hold the pen like it's the ladder, see when the wall pushes, which way does the pen rotate? Counterclockwise? So counterclockwise torque is negative, clockwise torque is positive.
But if you push it down with a painter, then
It goes clockwise.
Clockwise.
Yeah.
So now the,
All right.
down at what's the force code?
I beg your pardon?
What's the force putting you down? 'Cause the wall, you got 596 newtons for the wall, pushing that way.
Right.
Distance.
Right.
Distance.
The distance is 5.5. You guys are dismissed.
That would have been epic.
See some hardcore examples.